builds in parallel. Let's say, for example, that I want to run a debug and a release configuration build, and I don't want the debug to run and then the release to run. By using this multi-configuration and this multiplier, I can put config as the multiplier, and then when we get to the variables tab, I could create a debug, comma, release configuration, and it will then go and say, I'm going to run the build on one agent for debug and the build on another agent for release, and do them in parallel for you versus having to wait for them to happen in serial. So you have some capabilities there that you can use to parallelize your build. Our repository, as we mentioned before, this was a Git Team Foundation server, so we have Git, GitHub, and we're going to use GitHub in a later module, or any external Git if you're using a different Git provider to host your private repos. If you had chosen a TFVC team project when we created this, you would have the appropriate options for TFVC here as well. I can obviously choose what repo out of that Git repository I want, what branch I want to build, and even if I want to clean the system every time I do a build on that one particular item, and if I want to check out any of the sub-modules that are inside of that repo that I'm working with. Variables. Variables is a central place where I can actually define a value that I want to be able to use throughout my build definition and not have to change it multiple times. Not only can I define a value here centrally, but I can actually encrypt its value as well so that people cannot see this value should I not want them to be able to go back in and change it. This will be great for passwords and other sensitive data that you're defining in your build. We also have triggers, so we were talking about continuous integration. One of the great things about continuous integration is it allows you to fail fast. If, as a developer, I'm working on code and I put in an error on Monday, but you don't tell me that I broke the code until Friday, the amount of time it's going to take me to fix that's going to be very long. But if I break the build at 9 o'clock and at 9:05 the CI build tells me you just broke the build, I know exactly what I was working on 5 minutes ago, and I can go and quickly correct that error. So CI has lots of great benefits. And simply checking this box enables CI for us. And this will work even if we're using a GitHub repo, which we'll talk about later. Not only do I want continuous integration, but generally we want what we call nightly builds or scheduled builds, and we can actually do that as well. And this is nice in our new build system to be able to do both of these on the exact same build definition. Historically, if I wanted to have a nightly build and a CI build building the same project, I had to create two different build definitions, one with two different triggers. But now I can use the exact same build definition and simply give it multiple triggers to have it run multiple times if I need it to. So it's really nice to be able to have a lot better maintainability of our build definitions. We also have the General tab, and we'll go into a little bit more detail on a couple of these items in a later module. But again, we get to define what our default pool is. We have the hosted pool, which is the one that we used, but there's also a default pool where you can actually go and add your own agents, and we'll teach you how to do that a little later. We can actually give a description of our build definition here. So I'm going to say this is for the MVA. And then I also get to control my build format. So if you guys in your organization already have a build number format that you're used to, you can come and customize ours so that we make our build numbers look exactly like you expect them to. In Team Foundation Server, we have the concept of project collections and also team projects. And we're able to actually secure and scope our build agents' access to either the collection or the project level so that we don't have builds going off and doing things that they shouldn't be able to do. We also have a timeout so that if a job takes longer than 60 minutes, we don't let it hang up your entire build system. We go ahead and kill that build for you. We can enable badges. This is, again, if you're using GitHub and you'd like to have that little CI badge on your Git repo, you can actually enable that badge by simply checking this box. And then we're going to talk about demands. Demands are requirements upon the agent for you to be able to build this particular project for us. And I'll show you when we add our own custom agent how we have what we call capabilities. So the capabilities of the agent are matched against the demands of the build, and when they match, we're able to then run that build on that particular agent. And you can customize these and add your own. And again, when we add our own build, we'll talk about that. I'm going to go ahead and save this change that I made to the description because it'll make more sense when we get to the history tab. Every time I make a change, I'm actually able to give a comment of what it was that I was doing when I made that particular change, so that we'll have an audit trail of all the changes made to our build definition. And I basically added a description here. And I spelled that wrong, description. And so I'm going to go ahead and save that and then move on to the retention tab. The retention tab allows us to control how many of the builds that we've done historically that we want to keep on our drop locations and on our build servers. Because if we start to keep them all, eventually we'll run out of hard drive space and our builds will start randomly failing because they cannot drop the bits to the drop location. In the past, we used to say how many do you want us to keep? And now we've switched it to how long do you want us to keep them. So any build that's over 10 days will actually automatically be deleted. However, if you do 100 builds a day, you'll have all 100 of those builds for that particular day. Where historically, we would have deleted 90 of those builds if we said only keep the last 10. So we have a little bit more flexibility here, and we're really interested on your feedback on if you like this change or should we give you more options or different rules for retention. And then finally, the history tab. And as you can see, I have two different revisions here. The original one where I added it, and then the update where I added the description. And we even give you the capability of going off and diffing these changes so that we can see exactly what it was that I changed in our build definition over time, which was something a lot of our customers were asking for. So given that quick tour of all the different tabs here, we should probably have a build that is now complete, and we do. And it gives us an orange icon here because our builds had a test failure just like I said it would. So if we go back and look at our build, you'll be able to see that we had some test failures here, and we're going to talk about that in the next module. But here's a nice overview. We can enable things like code coverage. We can associate work items, so we get that full traceability of the items that we're working on that were actually built as part of this particular team build. So that's a quick look of how easy it is for you to actually set up continuous integration using team build.
Very cool. So I noticed you had one spot there where it had filter for continuous integration. And it was a very kind of targeted discussion there, but what would be some reasons why we might want to use the filter for CI?
Oh, the filter will allow you to be able to drill down to a particular folder or repo that you're actually trying to monitor, right? So I don't want CI every time you check in anywhere in our repo to trigger a CI build and start taking up build resources. There might be a specific folder or specific project in a repo that I'm actually trying to monitor, and I can drill down right to that folder and say only watch items that are in this folder or below, not everything else around it. That's going to cause noise in my CI.
Makes sense. Okay. Well, there were quite a few tasks that you had available to you. So maybe you could explain a little more on what are all of the options that are available, perhaps even creating custom tasks, or
sure.
What are some of the other customizations that can be done?
You can plug into our system from external systems. We have REST APIs. We have other types of hooks that you can actually use that will give you access to our not only build system, but VSO in general, right? So if you want to get to our build logs, test results, our work item tracking system, we have this rich API that you can use to exploit that. But that's not the only point of extensibility we have when it comes to our build system. We also have service hooks. So we're going to be using a service hook when we start working with things like GitHub. We want GitHub to be able to, we want to be able to monitor GitHub for check-ins to a repo so that we can then trigger CI from our side. So we want to be able to hook into other people and allow other people to hook into us as well. So we want to have that both ways of service hooks so that we can give you that rich functionality even if you're not just using all Microsoft. And then finally, after that, we have custom build task. And I've actually created the one that's highlighted. I was honored to be able to speak at Build this year. And during that demo, I was using deployment slots in Azure, which is a really cool feature that allows you to have zero downtime deployment from one slot to another on your Azure website. Well, because we were in preview, the teams didn't have time to go write a task that would simply swap my slots for me. And what was really nice is that I was able to go to the open source repo of all of our tasks, get a quick idea of how the tasks were written because they're all open source, and quickly wrote my own task and uploaded it to the system so that I now had a first-class citizen that would simply swap the slots for me, making it very easy to use. We have the generic PowerShell task, which is fantastic task, because the mantra for our build system and our future release system is if you can show me a command line, I can do it from our build system. It is that simple. So when someone says, well, can you use tool X, or can you use tool Y, or can you run this test or that test? My answer is always the same. Take me to a PowerShell, and let's see if we can write the commands necessary to perform that particular action.
Or shell script or batch script.
Exactly. Anything from a CLI.
Something that doesn't require you to sit there and click a button
absolutely,
to do it. Yeah.
Absolutely. So I say a CLI. Any command line interface that I can exploit, we can exploit it during our build. So our build can literally do anything that you can do from a CLI.
Yeah.
And we can strategically put it at the right point. So it's very extensible from that point as well.
And what I will say is that Chef and Docker icons aren't smiley faces, although we got a lot of love for Chef and Docker. But due to all of the restrictions we have on this course, that's why we have to give you the smiley face. So,
but they're smiley faces because we have a great relationship with both of those organizations, and their tasks are already inside of our gallery. So big fans of Chef, big fans of Docker, and they integrate well with our products. But as David said, for some reason we can't show their little logos there.
Yep.
Big fans though.
Cool. All right. Well, with that, we're going to put a wrap on this build fundamentals and continuous integration module. So stay tuned for module 3 next. Welcome back to module 3 of enabling DevOps practices with Visual Studio Online Build. There we go. In this module, we are going to talk about working with build agents. Now, Donovan already has shown you, hey, that hosted build controller agent